Fizyr is a Dutch company, a spin-off of the university by a professor. And we apply deep learning to enable robots to grasp unknown items and parcels. Like this envelope, you cannot program it. Every time I drop it, it will be different. So that's something that we, like a kid of 1 or 2 years old, is able to see, okay, this is an envelope and I can grasp it. That's in essence what we do. And I will show you a short video why it's still needed in the business. So this is the practice worldwide, 7 times 24 hours a day, where all parcels are still being picked by humans 7 times 24 hours. So small parcels, big parcels, DHL, UPS, Federal Express, PostNL, La Poste, you name them. They all rely on operators to pick those parcels. And so this is just a few examples of the industry where we are currently automating. So you get the picture. Okay. So what do we solve? So we enable a robot to grasp those items and to pick them regardless the size, shape, color, or how they are stacked. And we use therefore a neural network, which is independent of the hardware. So you can use a camera, a robot, an anti-factor, and it can simulate both the items, where Mike Strijbos will explain more, as well as parcels. So the system works as follows. It creates an image of the parcels. So you see the black envelopes on the bottom, and it also uses a 3D image, so a point cloud, and finding the grasp poses in 6 degrees of freedom, which is simply X, Y, Z, and where to grasp and to simulate. And that does it very fast and very robust, and so it can do it 7 times 24 hours, whereas humans, of course, they have to take a break and eat and sleep, etc. So the essence, what we do is we find the place where a robot can apply suction with a gripper. And so we look for a surface where to apply suction. And you see the drinking cup as an example. And we look for a flat surface where the suction cup can apply the vacuum force to simulate. We are unique as company because we grew bootstrapped. And I think that the same applies for Inter in the Netherlands. We did it step by step by step. And one of the first projects we did, and it's still in operation worldwide from America to Japan, it's picking the corners of towels. Nothing to do with e-commerce, but still it's feeding a folding machine. So the towel gets folded and then with the logo on top presented, and then it can be reused. So this is something we did, and this is the power of a neural network. So it distinguishes between a soft corner and a hard corner, and it finds, you see the yellow, blue, and red point, defines the point where the robot can grasp the towel and then feed it into the machine. Just an example, but it's so powerful, and it's something that's how we could grow our company based on these clients. This is an example of item picking, where we challenge people to put unknown items into a bin, and then the robot will pick them. So it looks for the surface where to apply suction, and it does it really smart. So this is just some examples, and Mike will show more of it. The essence, what we do is to first see where one object starts and the next one ends and the next one starts, is to do object recognition, and which is the key element, the fundamental of applying a robot. Because if you don't see the difference, then it tries to pick in the middle, and then maybe it has 2 items in the gripper, and then you have a problem. So in this case, you can see our bounding boxes coming from the software and finding the right envelope to pick. The same for depalletizing, we do a lot. So decanting, depalletizing of trays in logistics. And again, it's ignoring the tape, and it's ignoring the pallet, and it finds the right boxes to pick. I like this example. We have several integrators that work on truck unloading or container unloading. And on the left, you see the image coming out of a handy, a phone. And on the right, you see the output of our neural network, including a confidence score. So even on the right top, where the boxes are very hard to see, the software is able to recognize every single box, classify it as a box, and also give a confidence score of 99.99 whatever percentage that these are individual boxes. So this is the basics you need to in order to automate. And then again, here you see the grasp poses where to apply force. I think this is a video. Let me start it. Yes, of picking clothing. We do a lot in clothing. This is one of our integrators, ABL Techniek, and this is just an example of picking and putting it on a conveyor. We do the same for depalletizing, and the same for item picking, where Mike will now say a little bit more.
Yeah, thank you, Herbert. My name is Mike Strijdels. I'm with Intralogistics Engineering in the Netherlands as well. Our company is specialized in automating intralogistics for our end customers. So a lot of customers that we have run their business in e-commerce, and it's our goal to automate the internal processes that they have with a lot of hardware and software. And initially, our company was founded as a software company, but at the moment, the project we do, there are a lot of meters or kilometers even of conveyors and other automating equipment in order to get an efficient throughput of the products through the warehouse. And I think you actually have a video of the machine that we're talking about, Herbert. Am I right? You have control of the presentation?
Sure. Then I have to share it again.
So in the warehouses that we build, a lot of processes can already be automated, but one very important thing is still done manually in the majority of the warehouses, and that is the actual order picking itself. So boxes with product, they often come to an operator, but still the operator needs to look into the box, pick the product, put it into the destination tote or carton or whatever the customer is using. So still manual labor there. And that is already automated to a reasonably high level. So the operator doesn't walk into the warehouse and finds his products, but the products come to the operator and also the destination boxes or cartons. But still an operator is needed in that area to do that specific task. And that's where our idea some time ago came out with a product that we now call GRIP. GRIP stands for Gantry Robotic Intelligent Piece Picker. And that is basically what it does. So basically, it receives product, and product can be anything. That's also why we teamed up with Fizyr, because we do not know upfront what the product exactly is. We have some minimum and maximum specification, but if it's round or square, or if it's in a cardboard box or in a sleeve, we don't know. We don't want to know actually, because our customers sometimes they have 10,000 and even more different products which we don't want to train. And then the idea is that we send those products in crates that are stored in a dark warehouse to this machine or a cluster of these machines, and that this machine automatically detects where these products are and picks them and places them in their destination boxes or crates. We took a video of that together with Fizyr some time ago, and I think, Herbert, you are about to show that, right?
Yeah, I thought it was in the presentation, but I can start it separately. So let me check that.
So in this video, you will see some footage of the machine while it was at our testing facility in the Netherlands. And at the moment, the first machine is actually being installed at one of our long existing customers in Belgium.
Sorry for that.
I will give just Herbert to then find it, but a few questions for Mike while Herbert's doing this. Mike, how easy is it to actually introduce such technologies into daily
It's very
operations?
difficult because it is new, it does not exist. And in logistics, often when it comes to an investment, it means that you need to know upfront exactly to the last digit when the return on investment is being made. And especially with a product like this, it is cutting edge technology. That's also why we use Fizyr software. It is cutting edge machinery, and therefore a return on investment is not as easy to calculate as you would like it. So finding a launching customer is a difficult thing, and especially with the last period of COVID in mind, where people are not able to travel or to come here and to visit us and to see how the machine is performing. That actually delayed our time to market quite a bit. The good thing is, as I mentioned before, we're actually installing it at one of our long-lasting customers as we speak. And our goal is to have it running in the beginning of next month. So we're really looking forward to that, because at that time we can also tell you who is the customer and provide you with actual footage of a machine in the field, which is, of course, an important thing to get it sold.
So I saw that Herbert has added it. So just a second to,
Yep.
Okay, the video.
Yep. So this is an animation with an exploded view of the machine. Basically, it shows the entire machine and its dimensions. On the outer side, in this case, you see crates and boxes, and they can run through one another. It doesn't matter for the machine. And in the middle, there's a lane that controls the stock. So that comes from, say, a dark warehouse. And on the outside, you have the orders, or it can be boxes or totes. In the middle, the stock conveyor, as I mentioned. And on top, a gantry or a large 3D printer, whatever it is you like to call it, but that's basically what it is. And with the technology that Fizyr provides us, we look into this source box, as it shows right now. And together with the data we get from Fizyr and scale that is integrated in this position, we identify if a product is being picked up, or in this case, a product actually fell out. So we noticed that the weight was not correct. And we therefore are able to pick up products from in various angles, because they will never be perfectly flat in a box, or in an angled position somewhere in a corner, or even in boxes that have dividers inside the boxes. So we are able to very flexibly, as you see here, pick up product and position it into a destination tote or carton. And positioning in our case means really putting it in there, not dropping it, but really positioning it. Majority of our customers sell products that are not cheap. So dropping a product in the middle of a box or in the middle of a cardboard box is not allowed. So we actually look for space in the box, and we place it there where it should be placed. And it can do that at quite a rapid speed, as you've seen at the end of the presentation, and I think also in one of the first slides that we still have available, right, Herbert? Mm-hmm. It shows some specifications of the machine and why we came to this. So could you share that, Herbert?
The specifications are like this?
Yeah, one of the first slides, I think, from my part of the presentation.
Then I have to get the slides back.
Okay, is that possible?
Yeah, sure, of course. Okay.
Yes.
We are always demanding to each other, so
yes, I think it will be possible. But one thing that Mike, you mentioned that the products that you work with are quite valuable. Is such technology mostly for very high value products, or can it be implemented for?
No, not especially. It can also be implemented for cheaper items, but especially for those more expensive items, it becomes also more important how you place them, that you do not drop them in the middle of a box or a carton. So that part of the technology definitely is a thing that is required when you go to the higher end of the market. But also for cheaper products, we have the technology in place that simply drops it in the middle if you would like that. But yeah, we feel more secure with looking for a position in a box, a space in a box, and putting the product there where it actually fits. So,
and this is what you were talking about, I think, about the dimensions.
Yeah, so this actually is some specifications of the machine and some graphics of it. So as I said, it's a fully automated robot picker. It can pick up to 1,200 pieces per hour, which is quite a lot, of course. It has the system is built around the vision technology of Fizyr. That's also why we do this joint presentation. So in the previous slide, if you could go back there, Herbert, yes, thank you. Yeah, this one. Yeah, this one. You see that this is the actual source box where we pick from. In this case, there's only one type of product in this box, but it could also be divided into 2 or 4 compartments. And we have received from the customer information about the size of this product. At least we hope that the customer can provide it. If they cannot provide it, we have to assume that any product is right. But if we get it, then we use the software of Fizyr to see if we can find product with that dimensions. And as soon as we lift it up, we also try to check if the weight that was supplied by the customer is subtracted from the box that we are handling at the moment. So then we know that we are only picking up one item for sure. So nothing is sticking to the box or whatever.
And I want to move to a few questions. One of them was, is it also proven, and specifically in this case about grip, but also in general, adding all of these technologies into the e-grocery industry where, picking an apple, for example, is quite a challenge?
Yeah, at the moment, the machine is focused on things that can be picked up with a vacuum gripper. But at the moment, we have an internal project running where we also look at these e-commerce groceries to have that done, because there's a lot of things that cannot be picked up by vacuum. At the moment, that is the way to go with this machine. But in the design of the machine, we already anticipated for other technologies to be implemented in the future. So we're not stuck to only vacuum, but we could also have real physical grippers added to the machine, for example.
And the other thing is, for both of you, but let's start again with Herbert. Where are people going? If we have all of these machines, what is the role of people? A very big question.
Now, let me give the example of what everybody knows is data warehouses. So it's where all the machines are running for the web services. Everybody knows that. And there are just a few operators, and all the computers in the racks, they're just doing their jobs, and the operator sometimes changes a board, replaces something, does some maintenance, etc. I believe in the next couple of years, you're going to see the first lights out e-commerce fulfillment centers, the first sorting centers, parcel sorting centers, where there are operators monitoring the robots, but a big part of the process have been automated. So in that sense, yeah, I often make a joke, we are in de-recruitment, but there is so big shortage of people in operation. And if you look at the work that's done late at night, middle of the night, 7 times 24 hours, I love those people to be with their kids and not working in a warehouse doing things that the robot can also do.
And Mike, what is your...
And I think in addition to that, Herbert, what we typically see is that indeed a shortage of people that are available to do tasks like this, but also some of these tasks that we automate, they are really monotonous. So some people like to do it, but a lot of people don't like to do them. And by automating or starting automating processes like this, it's not that from the get-go you can automate all picking processes within a warehouse, but if you could already start with, let's say, 70%, that means that you have a less big demand for human resources, and a lot of monotonous jobs can be done by machines like this, and then the more challenging jobs can be done by humans, which is also the things that humans naturally more like to do instead of jobs like this. So yeah, it goes both ways, I guess.
And finally, Mike, how is it, you mentioned that no, it's very hard, or was very hard, to bring people and show them how this is working. How easy is it for logistics companies to think, hey, this is something, a road that maybe is worth exploring?
Yeah, what we, for example, did in the last year when it was pretty much impossible to travel or to visit us, we asked our customers, send us your typical products, send us your challenging products, and then we first investigate whether does vision support this? Can Fizyr software detect the product and where we should grasp it? And then secondly, can we pick it up? So if it's a sponge, then we cannot pick it up, for example. If it's too small to detect, we cannot pick it up. So we did a lot of sending back and forth goods and making video material and trying to explain why some things work and some things don't work. And that helped us quite a lot. But then in the end, yeah, it's not a very cheap machine. So people really want to see it up and running.
Yes.
So we now in our test facility in the Netherlands have a machine like this up and running, and that we can invite customers to come over and bring their own products. And that's becoming more easy currently, I'm fortunate enough to say. And then they can come over with their products. We simply put it in and we immediately see if it works or not. So yeah, that's the direction we're heading. And especially having a machine like this in the field running, will help sell, of course, for sure.
The proof of the pudding is in the picking.
Yeah, for sure. Yeah.
Thank you very much both for your time. After we finish, people will receive a bit more information with your presentation and also from you as well. Thank you very much, Mike and Herbert.